US Physics Olympiad, year 2019, USAPHO, final round. This examination consists of two parts. Part A has 3 questions and is allowed 90 minutes. Part B also has 3 questions and is allowed 90 minutes. Problem A1. Collision course. 2 blocks A and B of the same mass are on a fixed inclined plane, which makes a 30 degrees angle with the horizontal. At time t equals 0, A is a distance L equal 5 centimeters along the incline above B, and both blocks are at rest. Suppose the coefficients of static and kinetic friction between the blocks and the incline are μA equal √3/6 and μB equal √3/3, and that the blocks collide perfectly elastically. Let VA and VB as functions of time be the speeds of the blocks down the incline. For this problem, use G equal 10 meters per second square. Assume both blocks stay on the incline for the entire time and neglect the sizes of the blocks. Question A. Graph the functions VA and VB for t from 0 to 1 seconds on the provided answer sheet with the solid and dashed line respectively. Mark the times at which collisions occur. This is the answer sheet. Question B. Derive an expression for the total distance block A has moved from its original position right after its nth collision in terms of L and N. Now suppose that the coefficient of block B is instead μB equal √3/2, while μA equal √3/6 remains the same. Question C. Again, graph the functions VA and VB for t from 0 to 1 second on the provided answer sheet with a solid and dashed line respectively. Mark the times at which collisions occur. Again, this is the answer sheet. Question D. At time t equal 1 second, how far has block A moved from its original position? Solution for problem A1. Question A. Graph the functions VA and VB for t from 0 to 1 second on the provided answer sheet with the solid and dashed line respectively. Mark the times at which collisions occur. First, draw a free body diagram for both blocks, and we can find that the acceleration of A points down along the incline. That's equal to g sine theta minus μA g cosine theta, which is equal 2.5 meters per second square. Similarly, for block B, we have acceleration equal g sine theta minus μB g cosine theta, which is exactly 0. Let's first look at the qualitative picture of the collisions. When block A slides down with acceleration before colliding with B, it moves with the acceleration, and block B is not moving at all. When the blocks collide, the total momentum of the system is conserved, and because MA equal MB, the blocks just exchange velocities, and thus B slides down with a constant velocity, and after a momentarily stop, A will again accelerate down the incline and catches up with B, and another collision occurs. Quantitatively, the first collision happens when we have delta t1 equal square root from 2L over acceleration A, which is 0.2 seconds. In that moment, velocity for the block A, acceleration multiplied by delta t1, which is 0.5 meters per second. After the first collision, the blocks will exchange velocity, and we have new velocity for block A is 0, new velocity for block B is 0.5 meters per second, and still acceleration, the block A is 2.5 meters per second and the block B is 0. Now we have to equalize trips to the second collision. So it means that 1/2 acceleration A multiplied by delta t2 square equal VB multiplied by delta t2. And from here we can find time between first and second collisions. That will be 2VB over AA, which is 0.4 seconds. And before second collision, block A has velocity 1 meters per second. And block B still had velocity 0.5 meters per second. After the second collision, they will exchange velocities again, and we have VA equal 0.5 meters per second and VB equal 1 meter per second. Again, we have to equalize distances for the trip between second and third collisions. We have VA multiplied by delta t3 plus 1/2 AA delta t3 square must be equal VB delta t3, and from here we can find that delta t3 equal 0.4 seconds. And now we have a total time to third collision equal exactly 1 second. Finally, we can draw a graph for all three motions and collisions, and it will look like this. Question B. Derive an expression for the total distance block A has moved from its original position right after its nth collision in terms of L and N. Solution for this question could be easier to get using a previous graph. Using this graph, we see that distance before first collision equal L, distance to second collision equal distance to first collision plus 4L, and so on. It means that after calculations we have that distance after n collision equal L multiplied by 2n square minus 2n plus 1, which is exactly answer for question B. Now suppose that the coefficient of block B instead equal root 3 over 2, while mu A is the same, root 3 over 6. Question C. Again, graph the functions VA and VB for t from 0 to 1 second on the provided answer sheet with the solid and dashed line respectively. Mark the times at which collisions occur. Solution for question C. Now we have that acceleration B will be exactly negative g over 4, which is opposite to acceleration A. So friction is larger than the component of gravity. Once B moves, friction acts to stop it. In this case, A will again move down the incline and hit B with a velocity 0.5 meters per second through time 0.2 seconds. Now we have a graph like this. So it means that after first collision, blocks will exchange velocity. So block B will get velocity 0.5 meters per second, and block A will stop. After that, block A start to move the same distance before collision with block B, but block B will stop exactly after 0.2 seconds after first collision, and both blocks will move distance L, and so on. That will be a graph for question C. Question D. At time t equal 1 second, how far has block A moved from its original position? Solution. Again, using this graph, we see that till 1 second that will be exactly 5 collisions, and each time block A will travel L 5 centimeters. So it means that total distance will be 5L or 25 centimeters. That was a solution for question D, and that was a solution for all problem.